Good evening, everyone. My name is Piyush Gupta, and I am going to present my project here, naming terahertz breast cancer image segmentation using custom unit. This project has been inspired from 2015 Rellenberg paper, which shows us about the custom unit implementation, and that have implemented here upon the medical imaging for breast cancer segmentation task. So this project is supervised by Dr. K. Prasad sir, and the first step that I have imposed here is importing the Google Drive. The whole project here I have been doing it upon Google Colab, where I have taken the whole dataset inside the Google Drive, and the dataset is in the form of EMF files. I will be walking through the complete steps how I have implemented it. Let us start it. So first step I have done is importing the Google Drive, where my all the contents regarding the dataset is present. Then I have imported all the dependencies: numpys, pandas, matplotlib, cwons, warning, torch, optims, PIL is used for the image grabbing inside the files, so that we can extract the images, we can import images from our Google Drive and to our Colab notebook. Okay. So now the commented section that we are seeing here, I have commented this section. This is regarding the patolib library. What this library does is basically the EMF files that are created, it needs to be converted to PNG or the JPG formats, because the unit custom segmentation cannot be done upon EMF files. And so for that reason I am using a patol library. But the reason for commenting this section is because Google Colab has one small bug in it, that whenever I run the Google Colab one upon time, it will what will happen is, because my all the content is stored in Google Drive, so for the first time my images once it is extracted, it will be stored in Google Drive, and then when I read the entire drive, it will again store the number of images twice. Then when I read the third time, it will triple the number. So that's why I commented the section after reading the notebook once. So what this does is basically I imported the patol library. The patol library extracts all the contents inside the notebook dataset for EMF terahertz breast cancer dataset. The file name that I have kept is EMF terahertz breast cancer dataset. Okay. So here what I have done is I have imported again all the dependencies like data loaders, torch vision, matplotlib, PLTs, PIL imports, glob. Glob is used for basically traveling inside the file libraries, so that we can extract all the information inside one file or the another file. The input directory that I have named here, or that I have been referenced to, is the EMF terahertz breast cancer dataset, and the output directory is EMF to PNG. So what basically we are doing here is basically taking the EMF images. The total number of images that I am having here is 73 images, which has been taken from one of the colleges from Hyderabad, hospitals from Hyderabad. So those 73 images are in EMF form. So first I need to convert into EMF to PNG format. So for this I'm using here the LibreOffice library, which is having all the packages for converting the EMF to PNG. Then I have created the definition of init length get item and cell.transform from PyTorch, which does the following task for the cancer segmentation with labels inside this whole of the commented codes. After that, since the images that I had received after getting it from EMF to PNG, the images might not be of the same sizes. Those images might be of different sizes. So I have used here transformation function from PyTorch, which resizes the images and normalizes the images with mean, standard and standard deviations inside the whole dataset. Also, I have converted the dataset into batches. The batch size that I have kept here is 4, and I have used shuffle equals to true, which means that the all the batches that are created here, those will not have equal number of images inside them, but we may have different number of or different order of images inside the data loader. Okay. So once I have converted all the image files to PNG, Now I want to inspect the image quality of the image quality from the Google Drive and extract here. Let us see how this is done. I've imported here PIL. The PIL is used for transversing inside the files for images, and the directory I've used here is content with EMF to PNG at the end, and then with using the PIL and the glob function here, I have displayed all the images that I have converted to PNG format. So we can see that some images are in small in size, some are big in size, and so on. Some are in Gaussian filter. These are because of the transformations that we have done earlier in that commented code. So for reference also, I have given the image properties function. I created image property function for image from the image file for a number of 5. So basically what I am doing here, I am just giving some sort of example or the basically some information about some of the images that I have kept inside with RGB scaling. What are the properties of that? The format is PNG, width height is 794 and the file size is 60 KB. So this is the property all around for every image. Not exactly the same, but all around for the same images. But the size will be remain the same because I have already done the transformation. So now the second task is, since in this breast cancer segmentation, I am using a different technique of masking with OpenCV. So what I need to do is, before going for the masking, I am taking the pixel intensity in the entire images. So the red color pixel intensity, the blue color pixel intensity, the purple color pixel intensity. I am trying to find out what kind of intensity that I can use for this purpose to showcase for clear masking inside my images. So for that reason, I have used here alpha equals to 0.7 with the pixel intensity of base name image path. Base name image path is basically the path that I have where my all the images are stored. From there, I am extracting few of the image pixel intensities. Like we can see for some of the images, the pixel intensity is 250. It is all about nearly 250. In some of the images, we can see that the pixel intensity is going near to 0 also. So in that way, I am able to identify that my all the images are near about more than 200. So that I can easily identify that my red color is the majority color that is showing for the breast cancer segmentation. So, and also I have given the total number of image files that it has been converted here. So since I had got 73 files in total from the Hyderabad hospital, so after running thrice the whole notebook, it has been converted to 219 files. So if I would not have commented the whole section from the above task, it would go on for more and more and would take more hours to perform the task. So so now comes the second most important thing. After going for the conversion and transformation, since for model training and for ensuring that there is no overfitting or underfitting, I need to take care of the number of images inside my data set. Since there are only 219 images, which are very less as compared to ImageNet or something that are already present in the internet, I need to ensure that the amount that I will be using here is quite sufficient for the custom unit to perform the entire segmentation task. So here I am performing the data augmentation for avoiding the overfitting. So basically I imported all the dependencies, created one directory, and use the transform function for resizing. And yes, I have also converted all the files and directed my tensors from transform to tensor. Basically what it does, convert image to PyTorch tensor, because I am using PyTorch here. Okay, after that I have defined the whole PyTorch data set according to my requirement with the label assignment, and basically reference the image paths, reference the transformations, given the image labels, and I am also assigning here that how much batch size I would be using. The batch size I have said here is again 4, because initially also the batch size was set to 4. So total images that are in dataset is 219 itself. These are the transformed images that I have created here. Now coming to augmentation, for augmentation I have to, what I am doing is I am using the compose function, the compose library or the compose function from PyTorch. Uh, what it does is we can change the brightness, we can change the saturation, we can change the contrast, we can change the hues and degree of rotation, flip, horizontal flip, vertical flip, reflection and many more things. By doing that we can create number of images from one images, and by doing this the images are not even identical, so that the training set will be more and more generalized. So here the same thing I have written here, that horizontal flip is 50%, vertical flip 50%, degree of rotation is 20, brightness 0.2, contrast 0.2, saturation 0.2 and hue 0.1. And and also I have resized and cropped the images as well for the segmentation task. Also keeping same the batch size 4 and suffer equals to true, because every time I need to ensure that the batch size remains this 4, because the number of images that is generated now is again 219. These 219 images are the augmented images. 219 images. Okay. So what I have done here is right now is, now since the image dataset that I was having was uh, 219, and I used transformations to check whether those images are as per my need or not. And after viewing the images, I can see clearly that those images can work for my binary masking. So now I need to increase the number of the dataset. So basically in this entire coded code, because I have again coded this section, because once again if I run it twice, thrice and multiple times, the number of dataset will continuously increase and it will take more hours to generate the task. So what I have done here is, in this task, again I have created the dataset expansion function for expanding my dataset from input directory to output directory using segmentation per image equals to 50. So 219 images were in the original set, 219 images created for the data augmentation, and after checking that the augmentations were correct, I converted it into 50. So the total number of the generated images will be 21,900. So which is a quantitatively a good number for the image segmentation to take place. So the final dataset before splitting means before using the sklearn split for uh, training, validation and testing, I'm showing here the augmented dataset for a number of 8 images, how they look. These are the image segmented or the image augmented from the old dataset that I can use for masking. Since we are done with the data engineering, now it is very important for us to set up the device agnostic code. This is very important since all the images here are converted to tensor, and those tensors will be having a lot of functionality of convolution, upsampling, downsampling, max pooling, bottleneck. Then we have more like striding padding for the unit architecture. So it will take a lot of time, and if I don't use here CUDA or the device, I do not set up to device agnostic code, the problem that will appear is that I cannot use the GPU functionality here for processing the task. So after doing the image segmentation and everything, I can see that now I can import the train test split, and the total number of train path, temporary path, validation and test paths. From that, the training set size is 15,330, validation is 4,000 and test size is 2,300. This is my complete dataset splitting, and the paths also I have saved here. The paths for the where the training dataset and the validation, where they are stored, and these are the visuals of each of the, like 5 from each set. Training set 5, validation set 5, and visualizing the test dataset 5. So this is the most important segment, which is the binary masking, which I have done using OpenCV. So if I can quickly explain this. What this does is basically I am using the OpenCV library to identify the